Hello and welcome to today's A-Team Group webinar on deploying knowledge graphs in the real data management world. My name is Sarah Underwood, I'm an editor at A-Team Group and I'll moderate today's webinar. Our expert speakers today are David Newman, Senior Vice President, Head of Enterprise Knowledge Graph Solutions, Data Management and Insight at Wells Fargo, Michael Poole, Executive Director, Head of Ontology and Semantic Modeling at Morgan Stanley, and Alex Brown, Chief Technology Officer at Didactics. I'll ask them to introduce themselves in just a few minutes, but first, so that you can get the most out of the webinar and using our platform. To the right of the video, you'll see two columns. One is for polls and the other is for questions. We'll be running 3 polls during the webinar to gauge industry opinion. So I'll let you know when the polls are coming up and you can vote in them. You'll also see a Q&A channel. Please put your questions there for our speakers and I'll put as many of them to the speakers as I can as we go along. So polls, please take part, and questions, just post them there and I'll ask as many as we have time for. So thank you very much. I'd also like just to tell you that if you'd like to read more about knowledge graphs, we posted an item on the topic last week on data management insights, so go there to find out a little bit more later if you'd like to. Enough of me and over to our speakers. David, please introduce yourself and tell us a little bit about your interest in knowledge graphs.
Yeah, hi, I'm David Newman. I head the Enterprise Knowledge Graph Solutions team at Wells Fargo Bank. I also chair the FIBO initiative, the Financial Industry Business Ontology effort for the Enterprise Data Management Council. And my interest in knowledge graph is that it is a transformational capability for data, and it is definitely something that we all must engage, and glad for this webinar that gives us an opportunity to talk about it.
Thank you. Mike, coming to you, please introduce yourself.
Yeah, hi, I'm Mike Poole. I work at Morgan Stanley. I've been working on knowledge graph and knowledge representation solutions for quite some time now, in a variety of spaces. And as David said, I fully concur. This is transformational technology that has potential to have a significant impact on the future of data management.
Thank you, Mike, and over to you, Alex.
Hi, I'm Alex Brown. I'm CTO at Didactics. Didactics is a vendor of data quality and matching solutions. And although Didactics is not a knowledge graph vendor per se, we do provide some of the crucial enabling technology required to do some of the heavy lifting required to construct knowledge graphs. We've also taken a keen interest in the knowledge graph space recently, and we've sponsored a PhD in knowledge graphs. We've undertaken a significant amount of R&D and also secured significant R&D funding in the knowledge graph space.
Excellent. Thank you very much indeed to all of you. Looking forward to sharing what we all know about this. But let's get started with an audience poll question. The question is, to what extent has your organization implemented knowledge graphs? While you answer the question, let me come to David, if I may, to set the scene, define what knowledge graphs really are, and talk a little bit about their key components.
Yeah, Sarah. So first, to understand knowledge graphs, we have to start with graphs. What are graphs? Basically, they're networks of connected data in the form of nodes and edges that can be traversed. A knowledge graph actually leverages an underlying graph, but what it does do is that it provides a layer of knowledge over that layer, that graph of connected data, by defining what we call an ontology. An ontology is a very advanced model that allows us to describe concepts and the relationships of these concepts. And we're able then to superimpose that over the graph in order to get a more holistic understanding of all the data that's interconnected. We typically follow a standard semantic language protocol called RDF-OWL, which allows us to follow international standards in defining this model of the graph. And then we need to think about what an enterprise knowledge graph is. And an enterprise knowledge graph is essentially where you have a web of interrelated knowledge graphs that will describe the multiple domains of information across an enterprise in an interconnected way. And the enterprise knowledge graph allows for an enterprise to really get control of its data and provide ways of alignment, advanced linkage and integration of data, as well as much better ways of governing the data.
Okay, we'll come to the detail of some of that a bit later. Mike, what would you say here?
Yeah, I think David summarized that nicely. I think the one thing I always try to emphasize with respect to knowledge graphs is they are at their core still just databases, right? We're not suggesting anything magical. They're databases, but the way that they're organized is what's so important. Their nodes, their edges, they allow us to have, and as David said, we have formal definitions for the kinds of concepts we have in the graph, and the utility of that is it makes it easier for us to integrate the knowledge and actually gain new insights from it, right? We can actually use that use those formal definitions to understand the graph as it sits and infer new kinds of connections or even new kinds of entities and things like that.
Okay, that's lovely. Can we see the poll results and see how our audience are getting on with knowledge graphs? David, would you like to comment on those results?
Well, I'm not surprised, of course, that we have, if I add it up, in terms of planning, implementation, limited extent, to some extent, we're looking at 60 or so plus percentage of organizations that are now starting to think about this. And that really very much aligns with, I think, the maturity of the whole knowledge graph domain. This is still a very new area, and it's a major paradigm shift. Things don't change that quickly. The relational model has been the prevailing paradigm since, I would say, databases emerged in 1985, which we're looking at about 45 years. So the fact that we see this level of interest, I think, is a very positive sign that organizations are beginning to see that they need to do something different in order to get out of the data quagmire they may find themselves in.
Okay, that's great. So thank you everybody for voting, and moving on, coming back to you, please, Michael. You touched on it, David touched on it. How are knowledge graphs different from all those technologies we know? What's different?
So I would say a really key difference is one more of I would say of mindset than technology. And I think traditional relational databases, they're usually designed with respect to a particular application. And so that's typically what you'll find, especially in a large enterprise, but in any enterprise, is a whole bunch of disparate databases, each designed to solve a different solution or a different business problem. And so a big thing is, as I said, the mindset. So there you're starting from the application and you're building on top of that. And what in a knowledge graph, what you're doing is you're really trying to get your arms around a conceptual space. You're starting with your data, and then you may shape that data or reuse it with respect to particular use cases and business cases, but it very much is a mindset thing. But I think the other kind of key, just from a very technical functional perspective, a really important thing about knowledge graphs is that metadata and it becomes a part of the graph. So we talked about ontologies, but also information like where the data came from, who owns the data, how it's being used. All that information is stuff that actually fits very neatly in a knowledge graph paradigm. So you end up the metadata and there's less of a distinction between the metadata and the data. Data quality rules can be part of your ontology, and it's very much more tightly integrated. So it's mindset and functionality in those respects, as I would say.
Okay, thank you. And David, how would you express the differences between these technologies?
Yeah, pretty much to extend what Mike was saying, that with the conventional relational database, we had data. And then, as Mike mentioned, the metadata is separate from the data, as well as the conceptual model of that data is separate in another space. And then the physical schema is totally separate. So we have a lot of siloed fragmentation within a relational model. You cannot connect all of this. But with a knowledge graph, you actually get, I would say, the intersection, the convergence of data associated with its metadata, associated with its model. There is no physical schema or model with a knowledge graph. We don't need that. But most importantly, you can link data with knowledge about that data, with rules that reflect the meaning of that data so that you could make certain inferences such that you could infer that if A has the majority voting, controlling voting shares of company B, and company A and company B are both corporations, then we could say that company B is a subsidiary of company A and company A is the parent of company B. You could make these inferences. That's all baked into the knowledge graph, while within a conventional relational world, everything is segregated, and the amount of effort in order to link all of this together is immense, because the paradigm simply hasn't been built to support that. The second point is that back to the nature of the graph, with a relational model, you have to execute queries to join data, and you're never sure what all the data is that you must join for that particular piece of information. With a knowledge graph, as a graph, it's all pre-linked, it's all interconnected, so that there is much less guessing about where the data is. It's all integrated, linked, and connected, which is a major benefit of a knowledge graph as well.
Okay.
Yeah, just to echo that for one moment. So I was going to say, I've had numerous use cases in which, someone were running queries in SQL that were hundreds and hundreds or more lines. They transform it into a knowledge graph, and because of the connectedness that David just alluded to, you'll have 6 or 7 lines that a business user can understand, because you're actually using the concepts and the links rather than trying to figure out which tables need to be joined, and that's actually a tremendous benefit of functionality.
Okay, thank you both very much indeed. And let's at this point take a little break for a second audience poll question. This one asks, what are or could be the use cases of knowledge graphs at your organization? And there's a little list there for you to select, and you can select as many of the items as are appropriate to you. So whilst you do that, let me bring in Alex to talk about why firms are building knowledge graphs and what use cases they're using them for. This list on the question, the poll question was written by me, so there may be other use cases. So Alex, over to you.
I think, Sarah. Yeah, I think certainly, what we're exposed to at Datactics would be, the challenge of linking siloed data and really getting value from linking that information together and obtaining that knowledge. And I think that also steps into the world of alternative data and linking your structured data that you might have with alternative data sets that, or we know, particularly in the capital market space, becoming increasingly important. I think on the other side, certainly from our perspective, maybe not enterprise knowledge at the enterprise knowledge graph level, but certainly at the knowledge graph level, is how applications can be enhanced using that kind of technology. So at Datactics, for example, we've now started looking at how we can leverage graph technology to enhance data quality, to model and analyze relationships between data objects. So by that I mean graphing relationships between data sources, fields, data quality rules, time, and then performing a network analysis on that graph to optimize data quality. So I think that we'll see graph technology being adopted into vendor products more and more, in the same way that we've seen AI being adopted into vendor products in the last few years.
Thank you. David, what would you say there in terms of use cases?
Wow, there are just more and more use cases, I think, exploding in the knowledge graph arena. Now, I cannot specifically talk about use cases at Wells Fargo, but I'll talk generically about what I think is emerging out there. So again, where the use case demands that the organization of the data be a network, a knowledge graph is going to be a suitable solution. So just to name a few of those, first of all, I would say customer 360 linkages is a very important one, where you could look at commercial type customers or retail consumer customers and look at the multiplicity of their relationships with the organization, with other parties. So that's one area that is very key, and it's a basic low-hanging fruit opportunity for a knowledge graph. Specifically in the commercial space, looking at legal entity hierarchies, where you look at ownership and control relationships, or where you look at a multiplicity of counterparties. It's all a graph, it's all a network, and imposing a knowledge graph over that is really the only way forward in this space. Data lineage for regulatory reporting, lineage of application flows for impact analysis. Looking at supply chains is another very major low-hanging fruit opportunity for knowledge graph, and looking at the impact if suppliers fail or for varieties of reasons, to see who are the receivers of that service across a broad chain of relationships. Technology asset management, looking at the interconnectivity of all the various technology assets in an operational environment for operational risk and impact analysis and capacity planning. Another very major one is looking at payments. Overall, payments are a network. And when we can look at the whole network in totality, we have a very good way of identifying financial crimes. So anti-money laundering efforts, fraud detection, all requires a network. And when we have that layer of knowledge injected into that network, we gain insights that we would otherwise have much more challenge in identifying. So there are quite a few use cases. I think we're still at the very beginning of really conceptualizing the opportunity with knowledge graph. Looking at a graph is very intuitively obvious, and those are all the beginning use cases. But applying knowledge to the graph is one that I think is going to take us some more time to really ideate on the opportunity. Let me give you one more example in that space where a true layer of knowledge is very important, in the area of data catalogs. So we may want to ask questions about our data, and using conventional metadata repositories that are devoid of a central nervous system, essentially a knowledge graph that understands all the conceptual meaning and relationships that define the underlying physical data elements, it's very hard to ask questions that are very broad. So you need that knowledge graph to ask it at the level of abstraction that the knowledge graph allows, where you could then ask at a high level, and the knowledge graph links down to lower levels of abstraction and connects all the physical data elements. As an example, one might be asked, where are all the national identification numbers in the organization for a variety of security reasons? There typically is no column in a table that is a national identification number. You're going to get different identifiers for different nationalities, but nothing as a broad abstraction. But with a knowledge graph, you could organize your data so that you could query the broad class of a national identification number, and you could ask it for all the things that are kinds of national identification numbers and how they are linked to the physical data elements. So you could query the knowledge layer to get access to the questions that analysts are looking to assemble the data. Data scientists have a tremendous need to wrangle data knowledge graphs will be a great asset for them. I could go on and on and on the use cases because we're just tapping a whole new untapped area. But I'll let you move on, Sarah.
Okay, well, let's see what people are using these things for. So good if we could see the poll results, please. And Alex, if you'd like to comment on these. And I didn't include in my list some of the things that David mentioned. Alex, what do you think about those results?
Hey, yeah, I'm not surprised about data analytics. I am surprised data integration is actually so high on there. I mean, I think we hear a lot of we certainly hear a lot of people talking about it. I was under the impression that this, on the integration side, it wasn't particularly successful, even though people were attempting it. So that does surprise me a little bit there, that it's actually being used in anger, which is great news, I think.
Okay, thank you very much for that. And let me come back to you, Mike, to talk a little bit about how knowledge graphs can best be built, sustained, and maintained. Obviously, if you're in a big enterprise, as we've been talking about, that's a lot of data, that's a lot of linkages, and things change.
Yeah, no, it's a great question, because it's not uncommon for these efforts to start out with a bang and then sort of fizzle out, because we talk a lot about enterprise knowledge graphs, and I think there's a tendency then for the thinking to be, there tends to be, to use if you use a saying, like, it tends to be kind of a boil the ocean approach, where it's like, oh, we've got all this data, and trying to come up with an enterprise-wide ontology and figure all this stuff out, and that can be quickly overwhelming. So I think the key thing, for getting a knowledge graph built is to actually, to actually identify the use cases that you need to solve, and to show value and the beauty of a knowledge graph, and when we talk about maintenance, is they're very, very flexible. So it's fairly easy for you to modify the graph, modify the ontology as you go. So I always say the first step is to identify some simple use cases. Don't necessarily worry about getting everything right, but do design and solve those use cases in a way that scales out, right? Like I started saying, that you want to have a conceptual framework. So you want that conceptual framework to consider the use case, but also how it might extend in the future. So I always say, start small, but think big as you're doing that. And I think the other, just speaking from just experience, a really key thing for building knowledge graphs and maintaining them and getting them used more extensively in the firm, there's two sides to it that are going to be really important. The input, you want to standardize, make it really easy, as easy as possible for people to put new data sets into the graph. That may mean, there's tools out there would give you a nice UI for that, but you just want to make that simple. So you want to standardize that pipeline and just make it really easy for business users or technology users to get their data sets in. And then the other thing on the other side is getting the data out. Who's going to be using it? So do you need to worry about visualization? Do you need to worry about query templates? Do you need to worry about APIs? But deal with those. That's part and parcel of it. And if it's really hard for people to get the data in, if you have to have some small group of engineers that has to be the pipeline to get any data set in, that's not going to work. So you want to think about scale, but you want to think start small, think big, and think about that data ingestion. That's really, really important thing. If people can just walk in and have their data in 4 hours, that's going to be it's huge for getting your knowledge graph built and getting people to use it and maintain it. So I think would be the key things. So, and then sorry, the one other thing, think about from the beginning. David and I both talked about the metadata. Think about that from the beginning. What kind of metadata is going to be important, and get that into the graph early on, so that becomes standardized and becomes part of the process as well, because that metadata is going to be what allows people to find the data, and it's going to help them to make the links and that sort of thing. So those are some kind of key kind of functional and representational areas I think people should think about when they want to build one of these.
Okay, thank you. David, what would you add there? I think you're unmuted. Thank you.
So the most important asset related to the knowledge graph itself is the model. And that model is something that must be a standard for the enterprise. So to start the, I guess, the evolutionary process within an enterprise of growing a enterprise knowledge graph ecosystem. And back to what Mike said was, you do have to start small, but you have to prepare to do it in the right way. You need to have standards within the enterprise. First of all, you need to have a standardizable model, which that would be highly expressive, which is why RDF OWL is emerging as the de facto protocol or standard for knowledge graph models, because of its ability to be reusable, and it's also web enabled. I'll go into that a little later. But in terms of the organizational process, you have to prepare ahead of time. You should develop a set of standards that identify, let's say, naming conventions for the concepts in the ontology, so that as other groups begin to develop their own models, they can all ultimately follow the same standardization. There must be governance in an enterprise. We have to have learned lessons from many of the mistakes that were made in companies over the last 30 or 40 years with the relational model, where it was the Wild West, where every application built their own database, and it was highly bespoke and incongruent with other databases for the same exact data, different labels, or for the same label, different meanings. And it was uncontrolled. And it was all focused on legitimate viewpoints to deliver very quick functionality to the business for business benefit. And so everyone was driven towards building these incongruent solutions, essentially. Well, let's see what we can take from that and lessons learned. And with the advent of knowledge graph, companies have a great opportunity right now to pause, to think about it, and to start it with the right investment. I would call that investment the definition or the creation of what we might call an enterprise knowledge graph center of excellence, where groups come together and plan out the deployment of knowledge graphs in the enterprise. And again, by defining a set of standards, naming conventions, file structure standards, what the process is for governance over the knowledge graph, the process for approvals of the owners of those key data areas, and how the concepts represented in these models will make sense and will be aligned with each other. That's a very important thing, to start doing that planning first, and then yes, execute in very small incremental steps forward. The beauty of an enterprise knowledge graph, if it's done right, is that it organically grows, and it grows by leveraging reusability, where in a planned way, we start use case by use case, bottom up, identifying within the use case the business elements that are critical, the definitions of those business elements, and the ability to transform those definitions into semantic representations that describe those definitions and how they're interlinked with other concepts. And then we abstract up by looking at, let's say we start with a home lending organization, and then we may also think upwards to, let's say, the definition of a loan. Is that unique to home lending, or is the definition of a loan something that could be abstracted at a higher level, at a loan or a domain level? Or is that concept something that should be abstracted at the enterprise level? And so this kind of dialectic occurs with the ontologists and the subject matter experts to determine where do we float up or right place that concept, so that we could optimize and maximize reusability in a very controlled way. So the enterprise knowledge graph will grow incrementally and organically over time, as long as we have the standards in place that will support the future rollout, and that we have the process in place to abstract up. And then, of course, we have to have the right source control capabilities. So all of these have to be thought out ahead of time so that we can orchestrate a very well-designed data strategy that allows for maximum integration, linkage, and interoperability across the enterprise. And it's all doable, and it's something that, just look at the last 35, 40 years, and that tells us in many ways what to avoid, as well as some of the positive lessons of that time. Let's apply that to knowledge graph.
Okay, thank you.
So if I could just chime in one more thing there. I think David said a couple of really important things. I think like getting naming conventions for IRIs correct, having ways to link data, et cetera. The one thing I found that I would kind of caution against, or just from the trenches, is people sometimes go into knowledge graph thinking, oh, if we can now just have a single definition for this concept and everything is going to be good. And I found that ends up sometimes being sort of a futile effort, right? Like if we're working at an international organization that has 8 different lines of service, it probably doesn't serve us very well to say we're now going to consolidate on one definition of contract, right? So what we've tried to do with that a little bit is to say some of those ontology decisions, a little bit like what David was saying, is to say, well, look, you have a definition of loan. We're going to keep that isolated to your environment. And I think, I've wasted time before in organizations to say, we need to resolve this important semantic question. Well, sometimes you don't. Sometimes what you really do is just to say, we're going to punt on that question. We can accommodate 3 different definitions of contract because we've made it very clear what each of them means, and then we can understand the differences between it, instead of saying, no, there has to be just one definition. A knowledge graph can accommodate the fact that there are different definitions, and the formality allows us to understand those distinctions.
Okay, thank you very much indeed. I think we've answered one question about where to start in terms of starting small with a limited budget. But let's look at a few other audience questions here. And Mike, if I could come to you. This one says, knowledge graph skills are hard to source, like architecting a knowledge graph stack, executing and maintaining it. What recommendations do you have for finding resources with those skills, or indeed training people up as an alternative? What would you say there, Mike?
Yeah, it can be hard. I think there's two answers I would give. There's first of all, if you can look internally, you don't necessarily have to find people who've gone to Ontology University, right? A lot of what we're doing here is not a radical sea change from the people who've done database administration, people who've written code for doing ETL, people who've been data analysts. It's not that difficult to train them, right? So I think you just look internally for people who are interested in data, or people who have the smarts to do it. I've seen people who can get trained up quite quickly in this. So I would say look internally. And I think the other really important thing to realize, especially in the knowledge graph space, there's a lot of tooling out there now, right? There's a lot of things. So I don't think people who want to adopt knowledge graph technology, that you necessarily are going to need it. Your team doesn't necessarily have to be that large to start it, right? Because there's a lot of tooling that facilitates the data ingestion and those kinds of things. So, and I guess the other thing I would say is, it might take a little work to find the people who can do it, but there are people out there. We recently had a job opening, and I don't think it's quite as bad as people think in terms of trying to find the people who can do it. So, but yeah, I guess I would say look internally, get training programs together, find vendors who can do that training. That's a useful thing too. And there's a lot of good tooling that you don't have to build it all from scratch. There's lots of great stuff out there to do it.
Okay, thank you for that, Mike. Alex, I have a question for you, which is probably rather indeterminate, but here you go. We've talked about knowledge graphs for a few years. Why is it only now that they're being implemented at scale? What's come together that's made mean that we're talking about them here. People are implementing them, as Mike says. People are hiring, that sort of thing. Why now?
I guess that one big driver is complexity of data and volumes of data. Maybe a few years ago, you could have a bunch of people who could maintain intellectual control over their data domains, and if they all got together, they could answer the question, these broad questions. Now, I don't think that's possible. The data domains have multiplied and are so much bigger that no real group, you can't get a group of people together now and ask them a question. And it's now got to the stage where the only way to do that is to automate it somehow, and providing that linkage, that knowledge linkage between these data sets is exactly the tool that we need to do that. So I would say in a large part it's being driven purely by data volumes.
Okay.
And of course, the technology behind knowledge graph is now becoming much more readily adoptable. We're seeing free versions of knowledge graph databases that you can experiment with, play around with. It's no longer like bleeding edge technology.
Okay, and presumably from where didactics stands, there's been a lot of work going on around data quality, because like all these things, without data quality, nothing really works properly. So they go hand in hand. Yeah. Exactly. Yeah. Excellent. And David, one for you. And again, this may be a little indeterminate. It asks, how is a knowledge graph different from an ontology? And at what point does a knowledge graph become confusing? I think you're on mute, David. Can you unmute yourself? Thanks.
Thank you. So how is a knowledge graph different than an ontology? I really don't see the difference there. I mean, one could say that the ontology is the model in many ways of the knowledge graph, and the knowledge graph is often the actual convergence of data that's been ingested from multiple sources into a graph that leverages the ontology to describe the meaning of that data. So quite often, the difference is somewhat blurred. A knowledge graph is typically not robust without an ontology, and the ontology by itself is often not of great value without its data. So the marriage of the two is where you get the power. Okay, that's great. Let's go back to my questions then, if we may. Thank you for your questions to our audience, and thank you to our speakers for answering them. So coming back to my questions, Alex, please tell us a little bit about the types of technologies, techniques, tools, services that are useful here. You mentioned that they're becoming more mature now. What should people be looking for here?
Yeah, sure. I mean, it's not just the actual software, but I think also the amount of resources available online for learning about knowledge graphs and ontology is rapidly expanded. I mean, I know that the EDMC, for example, do an awful lot in this space. In terms of technology, I mean, some key things I think from our perspective would be ETL, building pipelines that can automate a lot of the knowledge graph generation, and those pipelines really do need to be robust. I think quality is key. So when we talk about quality, often we think about quality of the actual data content, but there's also quality of metadata. It can be really important. Don't underestimate how many times table column names have been misspelled and things like that. And I think when it comes down to the actual graph data itself, the data that's being modeled, the matching, I think, becomes quite significant. So when you're inferring relationships between data elements, it's not just a question of necessarily looking at the metadata around it. You can also look at the content and infer relationships based on the content. And in order to do that, you generally usually have to do some sort of advanced matching, right? Not just exact matching like you do in a relational database where it's like, oh yeah, this primary key equals this foreign key. It's more the case that you need to do advanced matching like fuzzy matching algorithms and NLP in order to uncover those relationships. And I think that could be really important, and I'll talk about that later on. And that all ties into the world of data discovery. Understanding what data discovery tools, understanding what your data sets can actually contain in terms of the metadata, and also the actual data content. Also in the data management landscape, so particularly interaction with data lineage and data governance, I think that's particularly interesting because there's a sort of like a reciprocal relationship where data lineage and governance can inform the knowledge graph building process, and then also it can benefit tremendously from the information in that knowledge graph as well. So I think that that marriage of lineage, governance, and knowledge graphs could be really interesting.
Thank you very much indeed, Alex. Mike, what would you add there in terms of useful text software, etc.?
Well, I hit on earlier, and Alex just talked about it too. I think it's hard to overestimate the extent to which you need to have good ETL support, right? Like that pipeline of being able to pull that data in and making that efficient and robust and reusable, and hopefully linked to your knowledge, right? So that I can find all the existing ETL jobs that exist for particular concepts. I think that's really kind of key. But I think this is also why it's important to think about the use cases, right? Because in my experience, there's a couple really key things. Are we looking to the business user who's trying to explore links between particular entities, or are we looking at trying to help the data analyst who's running some complicated machine learning algorithms? That makes a big difference on what kind of comes out the back end, right? If you can build a beautiful knowledge graph. But if you have business users who are just saying, look, I just need this to find out, links between the organization, and you haven't thought about the visualization or the query component, it's not going to work. Similarly, if you're saying, no, this is really a data analyst tool, then you've got to make sure you've done the data cataloging so the data analyst can find that data, that they can have a way to ingest it into their data and analytic pipeline, or that they can run graph algorithms on your graph. So use case, it's hard to answer that question about the techniques without answering your question, what are we going to be doing with the graph? I think that's a key thing. But I will say another thing, note from the trenches, don't underestimate the extent to which it's important to worry about query performance and inference, right? If we're serious about using ontologies and we want to draw new conclusions from it, I think Alex spoke to this as well. Make sure the tools you're getting are going to be performant, right? You don't want to spend all this time building a big, beautiful knowledge graph, but when people query it, it takes 8 minutes to get a response, right? So worry about the query performance, worry about what kind of inference support you're going to need, and find ways to put that into place, I think. So I would say, the visualization, I'm always careful not to emphasize that knowledge graphs aren't just about visualization, because it's usually the first thing people think about, but it is important. And so worry about getting, the right kinds of front end tools on it. And I guess the other kind of thing, that we're thinking about more, and I'm sure other people are thinking about as well, is just kind of cloud solutions, right? Like how can we leverage the cloud? How can we leverage, let's say, existing cloud solutions to make our graph databases more effective? So I would think about developing plans that can scale up to that, so we can really make the solutions more performant. We can offload some of our resourcing to the cloud and ingest external data sets more easily and things like that.
Okay, thank you. So coming over to you again, David, can you talk quite briefly, because we've got some more questions and not enough time, about the challenges of deploying knowledge graphs in the existing data management landscapes? Mike just touched on that. How does that work? Where are the problems?
So I would say that there are two kinds of challenges. There are organizational challenges, and there are also technology challenges. None of these challenges that I'll mention are major impediments. I would say they're more natural growing pains of introducing new technologies and capabilities into an organization. So for example, the organizational challenges have to do with simply being able to get the different groups in an organization to have their opportunity to review diversity of knowledge graph tools, so that some of the right tools could be finally defined and adopted in an organization's technology standards catalog. So these are basic vetting capabilities that must happen, and that takes time. So, and today, obviously, with a greater focus on risk management, it takes a little longer than it may have taken in the past for other relational solutions many years back. It's no longer speed dating. It's almost now short of marriage. So it's a huge commitment. And that organizational challenge is really something that we'll work through over time, as it's just a natural reflection of the times, that things will take longer to bring into an enterprise, to kick the tires and find the right tool. The other one is that we're still in a horse race. There are many vendors emerging into this space. We don't know which of those vendors are going to be the winners of that horse race. So we have to place bets very carefully by testing out the different vendors and make sure that they're right for us. And there's, in the knowledge graph space, technically there are the RDF semantic graph databases, there are the labeled property graph databases, there's the emergence of virtual graph vendors as well, where ETL is not even required. And so, how does an organization make sense of this? So that's still part of the organizational growing pains. The main point, though, that I want to again reemphasize is that as long as the organization is committed to a semantic model, and that semantic model can be utilized or ingested by the tool, then it's a good thing. Okay. So the last point on the technology challenge, again, it's a matter of the ability to test and deploy and test and retest in terms of the scalability question. I believe it's quite evident that knowledge graphs are as highly scalable as relational database capabilities. We could see evidence of that at the Google levels and the Amazon levels. They're all using knowledge graphs that are highly scalable. Question is, will these be executed within on-prem, or will companies be moving to the cloud? And eventually, as they do move to the cloud, scalability is not a question. All of these will be remediated in time.
Okay, I'm going to come to Mike next then and ask him how they're going to be remediated in time and how firms are going to show an ROI from their investment in knowledge graph technology. Mike.
Yeah, so I think the answer to that is one, like I think it came up earlier, like in response to your question, why are firms getting interested in knowledge graphs now? And I think the big ROI is the thing that I often emphasize with knowledge graphs is there's all kinds of information in our data that everyone's starting to recognize that, right? That their data is valuable, and people are throwing machine learning solutions at this stuff, trying to wring data out of it. You can't really effectively you can't wring you can, but you can wring information, knowledge out of your data much more effectively if you put it together. You can have a much more scalable machine learning architecture if you have a framework within which you've normalized the data, which you can understand the concepts that are related to each other, when you can understand that this data element actually means the same thing as that data element, even though they have different names in the physical schemas from which they came. So I think the big ROI thing is going to be everything that we've talked about utilizing your data. the way to realize that is making the knowledge graph the framework within that knowledge that data utilization occurs. And I think, and we've been getting pressure, where I am, just to say that, like, how do we, we've got all this data, how do we get these new new information from it? And the key is to say, I want my frontline analyst to be able to figure out, what's the impact on this particular portfolio if something's happening in, this particular country, like some unrest. Well, how do you do that? Well, you have to be able to chase the links and understand all these different things are linked together. So.
Okay, thank you very much indeed. Challenges and solutions there. So, Alex, do you want to just run us through a sort of implementation and how it could go?
Oh, yeah. Well, I'll reiterate, Datactics isn't a knowledge graph vendor, but we do provide the technology to do the heavy lifting to enable construction of knowledge graphs. Earlier on this year, we undertook a project to build a knowledge graph and populate a graph database from UK companies' house data and other data sets from the Office of National Statistics here. Probably about 9 different data sets. Companies House, for those of you who don't know, is an open register for all companies in the UK. And what we wanted to do was to build a knowledge graph and populate that graph that linked company entities to persons of significant control and could actually link those to other external data sets as well. I mean, you might think that things like that should already be done in the data set, but that's not quite how it is. And so this kind of things are actually a common challenge for things like KYC, due diligence, and of course, investigative journalism. So some of the results that we've seen of in the UK press here quite recently. So what we sought to do was to demonstrate the importance of really on data quality matching, which is, of course, our USP when building knowledge graphs. So what we tried to do was take data verbatim from these sources, sort of like almost throw it into graph databases and generate a knowledge graph to just see what you get out of the box. And then compare that with a more refined approach where we'd first ingest data, cleanse it, normalize it, discover links using fuzzy matching and NLP. And then the output of that is high quality data that can be readily imported into a graph. And I won't spoil spoil the results because they're yet to be published. But what's really apparent is that it's very important to carefully prepare data and to have some sort of quality controls whenever a knowledge graph is being generated, or whenever a graph is being populated. And I think this is very significant if your knowledge graph process is going to be decentralized, democratized, where you want actually end users to be populating it. Otherwise, if it's wrong, there's a big problem. So, if the actual data is wrong, you could miss relationships between nodes. You could miss that 2 nodes are actually the same thing. So you need to be careful that your knowledge graph is giving you the complete picture, which becomes very important if your knowledge graph is feeding something like a KYC process.
Okay, thank you very much indeed for that, Alex. Obviously, many components to getting this right. I think we have time to squeeze in a final poll. We may not have time to talk about it, but let's squeeze it in. It asks, what extent of business and operational benefits is your organization gaining, or would it expect to gain from the implementation of knowledge graphs? So perhaps whilst you're answering that question, David, would you like to comment on the benefits that you can gain here?
Yeah, sure. So some of the overt benefits of a knowledge graph are ultimately improved insights across the data result in improved decision-making for the company, for its own operations, and for insights about its customers. So those are very profound, I think, benefits of the knowledge graph. Another one is that as a result of the reusability and the data linkage, we will see significant improved economies of scale and efficiencies of working with data across the company, faster search times, faster access to data that is needed, and ultimately that results in cost reduction. as well as in other areas, improved risk management and insights for all areas of risk are other key benefits of the knowledge graph. So in general, the overall tide of data rises across the enterprise for a variety of these improvements that will accrue over time. Now, regarding operational benefits, again, data linkage and data integration is much more easily facilitated using the knowledge graph, and that is something significant. With also, to Alex's point, the convergence of machine learning with knowledge graph will result in improvements in identity resolution as party A, the same as party B, as well as insights in the ability to capture unstructured content into a structured form in order for analytics to occur. Customer complaints can all be captured in a structured form, customer communications. So tons of business and operational benefits.
Okay, let's see what our audience says, if we may. Thank you. Well, as you say. Mike, would you like to just comment on those results?
Yeah, let me just read them first there.
For anybody else who can't see them, we see 38% respondents saying significant business benefits, 38% saying some business benefits, less on the operational side, 13% some operational benefits, and 13% saying no benefits. Mike?
13%. Wow, was this before or after? When was this poll taken? Just before the.
What have we done?
Oh my goodness, we haven't sufficiently convinced them. Yeah, no, I mean that's I guess that's good that there's always the 13% who on a poll that think Elvis is still alive. So I will take that. But yeah, I mean, there are, of course, as I say, I would think there are fairly significant business benefits and of course operational benefits as well. I think it's a paradigm change, right? I mean that's a big part of this. It's so in some sense I instead of just simply trying to say, well, what are the business benefits? I think it's like to say what I kind of turn around and say what aren't the benefits? What is the benefit of continuing to handle data the way that we have, right? And I think it's almost like you need to have this paradigm shift. So it's less of an add-on and more of a change in approach. But yeah.
Okay. Excellent. Thank you for that. Thank you for voting, everybody. And we are very close to time. So let me ask our speakers what advice they would give to practitioners working on knowledge graphs. First, Alex, a few words from you, please.
I'll just summarize what I've said. I think it's really important to have robust pipelines, automated, reproducible, auditable pipelines to produce the knowledge graphs and to populate the data. I think that the results of data of the knowledge graph queries are obviously improved by having good data quality in the first place. Avoid the garbage in, garbage out scenario, and then understanding that related to data quality, the matching between elements is basically the quality of the links between elements in the graph, and that's very important. That's really what you want to find. So data quality is paramount.
Thank you. Mike, a couple of words?
Yeah, as I said, I think the big things I would say is get the right tools early. That's going to be really important. So get the right knowledge base or triple store that you need. And I would say, as I said, I'll just repeat myself. Think big, or start small but think big, right? Like don't try to. You don't need to solve everything. But solve small problems but think about where that's going to fit in the larger framework. But I really think this is a really good example of knowledge graph implementation where the perfection is the enemy of the good, because if you were trying to solve the whole thing before you get started, you never will. So just jump in, solve some use cases, get some good tools, and just iterate on that.
Okay, I think we're going to have to leave it there. So thank you very much. And thank you for your questions. We have more than we've answered, so we'll try and take some of them offline after the webinar in the next few days. So thank you for that. And thank you indeed to our speakers for sharing their expertise and their experience. And thank you too to Didactics for can't say it right today, for sponsoring today's webinar. It's been a very good conversation, and I think there will be more. Before we close up, a few 18 group items that may be of interest to you. If you scroll down your screen to additional options, you can download our ESG Handbook 2021, our recently released Regulatory Data Handbook 2021-2022, and you can also register for our next Data Management Summit, which we'll host in London and in person, hopefully, in May 2022. That said, that's it for today. So thank you again to David, Michael, and Alex, and thank you to all of you who have taken part in the webinar. Please complete our feedback form, as we're always keen to hear your views and improve our products. Meantime, thanks again and goodbye.